Okay, y'all, so we're doing matrix multiplication, and I guess the most important thing for you to know about matrix multiplication is this last little statement down here. It is not commutative. So remember, the commutative property says that I can multiply in any order and I'm going to get the same answer. So like if I did 3 times 6 is 18, then 6 times 3 is also 18. That's the commutative property. With matrices, it doesn't work that way because of the way you have to multiply them. So you're going to multiply a row by a column and get a number, and multiply a row by a column and get a number, which will make a lot more sense when we do some examples in a minute. But what I'm trying to make you understand is that when you're multiplying matrices, the rows and the columns have to match up in order for things to work. They don't have to have the same dimensions like with addition. What it is you're going to look at the dimensions of your two matrices, and when you write out those dimensions, like if you look right here, if I write out the dimensions of matrix A and the dimensions of matrix B, then these inside numbers, which would be the columns of the first one and the rows of the second one, have to be the same because of the way that we multiply. And then we get an answer that is these outside numbers, so the rows of the first one and the columns of the second one. All right, now I know that probably was like, what is she talking about? I get it. It's not hard. It's just weird to try to explain. All right, so we're going to do some practice, and I promise it'll be really simple by the time we get done. All right, so to recap, what we need to know about matrix multiplication is that in order to multiply, the first matrix number of columns must be the same as the second matrix number of rows. And if you write the dimensions out like this, then it's just simply do these middle guys match. If so, then yes, you can multiply, and your dimensions of your answer are going to be the outside numbers. And we need to remember that matrix multiplication is not commutative. I can't multiply A times B and then B times A and it get the same answer. Sometimes I can do one and not the other. Sometimes I can do both, but they won't have the same answer. All right, so sorry, I forgot to put my phone on silent. Okay, I was making sure that I covered everything that was in here, and I did. Okay, so the first thing we need to be able to decide is just, can I multiply? So on these two examples, we're not actually going to multiply. We're just making the decision, can these be multiplied? So to make that choice, you're going to look at the first matrix and think about its dimensions. Well, this has 2 rows and 4 columns. So this is a 2 by 4. This one has 3 rows and 4 columns. So to make the decision, can I multiply? You look at the columns of this one and the rows of this one. Do these numbers match? They do not match. All right, so that tells me that I'm not going to be able to multiply. So we would just say not possible. If I was asked to multiply, my answer would be not possible. I'll try to write that a little bit neater. Those of you not in my class, I can write a lot neater than this. Okay, so for the next example, if we are looking at the dimensions here, we have a 3-row, 3-column, so a 3 by 3. Here we have a 3-row, 2-column, so a 3 by 2. All right, so first thought, do these match? Are the columns the same as the rows here? The answer to that is yes, they match. So we now look at these outside numbers, the rows of the first and the columns of the last, to know that my answer would be a 3 by 2. So I haven't actually multiplied anything. We're just looking, can they be multiplied? So number 1, it's a no, because the columns of the first one don't match the rows of the second. On number 2, it was a yes, they can be multiplied. The columns of the first matrix match the rows of the second. There's the same number of columns in the first as our rows in the second. And then the dimensions of the answer would be a 3 by 2 because that's the rows of the first, the columns of the second. Okay, so let's do some examples of actual multiplying. All right, so here they want us to find the indicated product if it's possible. So remember, always check, because with matrix multiplication, it may not be possible and you can just stop and say not possible. All right, so if I want to do A times B. So if we look at matrix A, this is a 3 by 2. Matrix B is a 2 by 2. And I'll go ahead and make, well, we don't need that one right now, so we won't talk about that. Okay, so if we're looking at a 3 by 2, and we're going to multiply by a 2 by 2, can that be done? Well, the answer is yes, because we match. So yes, I can multiply, and I should end up with a 3 by 2 when I'm done. Okay, so here we go. Again, this is not difficult. It's a little tedious, so make sure that you're following along. If you're taking notes, I would suggest that you don't try to write anything down, that you just watch what I'm doing. And then at the end of the problem, you can pause and write it all down, or go back through and write it down while you're listening again. All right, so if I have matrix A, I'm going to go ahead and rewrite them so that I can just have them a little handier. All right, so I want to do this times this. Okay, so we are going to need some room to work. All right, so, and I think I gave myself enough room. Okay, so the product, sorry, I lost my word. The product matrix here, the answer that we're going to get, should have 3 rows and 2 columns. Okay, so to get this entry right here, the number that's in the first row, first column, we're going to look at the first row and then the first column. So if I take these and multiply by these, okay, I'm not going to be able to keep up the color coding the whole time because it's going to get like way too crazy. So I'm just trying to make you understand what I've got going on here. I said these and only boxed one thing. You know, whatever. Okay, so we're going to do this times this plus this times this row times this column. So -1 times 1 plus 4 times 0. That gives us this one number. So my final answer matrix down here, this first little entry is going to be -1 plus 0, so -1. All right, so back up here, we're trying to get, we'll say, we'll do this one next. We're trying to get this number. Okay, so we're going to take this row and times this column, because we're in row 1, column 2. So we're going to multiply row 1 by column 2. All right, so the first video told you how to label elements. It's really helpful that you understand that this element that you're trying to find is in the 1, 2 spot. It's in the row 1, column 2. So that tells you you're multiplying row 1 times column 2. So we're going to say -1 times -2 plus 4 times 7 to get that number. All right, so what's that going to be? 2 plus 28, so 30. All right, so I may run out of colors, y'all. Okay, so now we're ready for row 2, column 1. All right, so row 2, column 1. I'm going to try to keep up with this color coding. Again, it's going to get a little crazy looking. Okay, so we're in row 2, column 1. So we do row 2 times column 1. So 2 times 1, don't know what that was. 2 times 1 plus 0 times 0. So that gives me just 2 to go in this spot. All right, so next we are in row 2, column 2. So we'll do row 2, column 2. So that would be 2 times -2 plus 0 times 7. So that gives me -4 plus 0, so just -4. All right, so next we have row 3, column 1. So row 3, column 1. So we would have 1 times 1 plus 2 times 0. So that's going to give us 1 plus 0, so 1. Let's see if I can find another color that I haven't used. There really isn't one. We'll try this weird little brown. Okay, so now we are in row 3, column 2. So we're going to go row 3, column 2. So 1 times -2 plus 2 times 7. So that's going to give us -2 plus 14, so 12. And then this is your final answer. This right here. All right, so again, rewind that and watch it again and write it down. Hopefully you followed my color coding. All right, so next example. We are given the same original pieces, but now we want to do B times A. All right, so remember that we start by looking at the dimensions. This is a 3x2, and this is a 2x2. Well, we just multiplied A times B, and we said, yay, they match. We can do that. Well, now we're doing B times A. So it's a 2x2 being multiplied by a 3x2. And when you look at these inside numbers, you realize that these columns don't match these rows. All right, so if you tried to follow that process that we just used, you would have rows without columns to multiply by, and or you would just have an extra set of numbers. It wouldn't work. So your answer to this is not possible, and we are done. All right, last example. All right, so we are going to do C times A. So let's look at the dimensions of those. We're going to use A. That one's a 3x2. And we're going to use C. That's a 1x3. All right, so they want us to do C times A. So if we do C times A, if we check our dimensions, we see that the columns of the first match the rows of the second. So yes, we can multiply, and we should get a 1/2 when we're done. All right, so here is matrix C. And we're going to multiply by matrix A. All right, so we should have a 1/2. I don't know if I can fit it in that. Let's scooch this over. We should have 1 row, 2 columns, so we'll make it a little wide. Okay, so if I'm going to get this first entry that's in row 1, column 1, then I'm going to use row 1 and column 1. So I'm going to have 2 times -1 plus 3 times 2 plus 4 times 1. And I knew this was too close when I put it. Let's move it way further down. Okay. Actually, I don't need this extra room down here that I made either, but it's okay. I guess we'll fix it. Sometimes I struggle with knowing how big I'm going to write. I apologize. Okay, so now we're in row 1, column 2. Row 1, column 2. So we're going to use the row 1, the only row, and the second column over here. So 2 times 4 plus 3 times 0 plus 4 times 2. All right, so then our final answer, this is -2 plus 6 is 4, plus 4 is 8. And then this is, I don't know why I changed my color. I'll put that back in blue for those of you who like things to be color-coded. What did I just say? That was 8. -2 plus 6 is 4, plus 4 is 8. All right, this is 8 plus 0 plus another 8, so 16. But I do want this to be black. Okay, so that is matrix multiplication. It's a lot of easy things. It's just, you gotta do a lot of it in one problem sometimes. So remember that when you're doing matrix multiplication, to take your time, because careless mistakes are gonna be your biggest problem. If you have questions, make sure that you reach out and ask, and go take your quiz.